Hi, welcome to Unit 7, Day 2, where we're going to look at properties of parallelograms. Okay, so we're going to look at 4 properties that these parallelograms are going to always have anytime you're told you have a parallelogram. We can't just look at a parallelogram or something that looks like a parallelogram and assume that it is, but if we are told it's a parallelogram, these 4 things will always be true. The first one is if you have a quadrilateral that is a parallelogram, then your opposite sides are, of course, parallel. So this side here, I'm going to put my little parallel symbol, and then my top is parallel to the bottom. Notice I put 2, it's just like with tick marks. I'm going to put 2 because it's a different set of parallel. Okay, but that's not all. My first property includes a little bit more. Not only are my opposite sides parallel, we're going to say and they are congruent. Okay, so that means not only are they parallel, but the left side is the same length as the right side, and the top is the same length as the bottom. That will be true for every parallelogram. The opposite sides will be both parallel and congruent. Okay, my second property, if a quadrilateral is a parallelogram, then opposite angles are congruent. So if I know how big this angle is, the opposite side is exactly the same measure. If I know how big this angle is, the angle across from it is exactly the same measure. Notice I didn't put the same markings on the ones on the same side. Just the ones across we know have to be congruent. The ones on the same side don't necessarily have to be congruent. They can be different. But the ones across from each other will always be equal to each other. They'll have the same measure, which means they will be congruent. My third property. If a quadrilateral is a parallelogram, then consecutive angles are supplementary. So hopefully we remember what supplementary means. We usually just say, oh, that means they're 180. But it's better to say rather than say they're 180, because that makes me think this is 180, this is 180. When I say consecutive angles are supplementary, that means consecutive angles add to 180. Okay? It's consecutive. Remember when we talked about consecutive interior angles, we said you could also call those same side interior angles. So when you see this word consecutive, that means they're on the same side of the parallelogram. So if I look at the 2 angles on the left-hand side, these 2 angles here, they're going to add up to 180. So let's just pretend this one's 120 degrees. That means the one next to it would also have to add up to 180. So this side would have, or angle would have to be 60, because these 2 angles have to add together to make 180. Now I just picked a side, but it could be any side. So that means the 2 angles on the top, they also have to add to make 180. So if this is 120, then this one over here has to be 60. The 2 angles on the right side have to add together to 180. So if this one's 60, this one down here has to be 120. And then look at the 2 on the bottom. They also will add to make 180. And so then what you'll see is you really can see that your opposite angles will also go back to that number 2 property. Your opposite angles will be congruent. Okay, let's look at my 4th and final property that we're going to talk about for our parallelogram. If a quadrilateral is a parallelogram, then the diagonals bisect each other. Bisect each other. Okay, so what that means is they cut each other into 2 equal halves. So if I draw in this diagonal here, and I draw in this diagonal here, I'm not going to end up necessarily with 4 equal pieces, but I'm going to have 2 pieces here that are the same length. That piece is going to be bisected, and then this one here is also going to be bisected. Okay, so it's important to note that not necessarily your diagonals will be equal to each other, but the diagonals will each be divided into congruent pieces. So that's important to note. The diagonals do not have to be equal. Okay, your diagonals do not have to be equal. Sometimes we end up with really funky looking parallelograms, like this here. Okay, and you'd see that this diagonal is way longer than this diagonal. Okay, but these 2 pieces will be the same length, and these 2 pieces will be the same length. Okay, so that's super important to remember is your diagonals don't have to equal each other, but they will both be divided into 2 sets of congruent pieces. Okay? All right, let's look at these 2 examples before we move on to a new video. It says we're going to state the property we're using to solve. And we probably need to start with, given the figures below are parallelograms. Because these properties are only going to hold true if this really is a parallelogram. This is only going to be true if this is a parallelogram. Okay? So when I look at my first one, let's see what information we have. I can see that the measure of angle D here is x plus 8. The measure of angle Y, or A, is y plus 9. And the measure of angle C is 3x. I don't know anything about angle B, but I do know that I'm working with angles. So I need to figure out which of my properties I'm going to be using. The only 2 that deal with angles are this one here in orange. My opposite angles are congruent, and my same side angles add to 180 degrees. So I do have some opposite angles, y plus 9 and 3x. I know that these 2 angles are going to be congruent. Okay, opposite angles are congruent. Okay, however, if I try to solve my 3x equals my y plus 9, I can't solve that because I have both an x and I have a y. So I'm going to have to pause on that one and look differently. Okay, so what else do I see? I see I have these 2 angles that are on the same side. So I know they are consecutive because they're both along the top. So these 2 angles I know are going to add together to make 180. And then these 2 angles along this side, I know they're going to add together to make 180. Because I know consecutive angles are supplementary. And I'm just writing that down because it does say to state the property. So I'm stating my 2 different properties that I'm going to be using. If I look at these 2, I'm going to be stuck with the same problem. X plus 8 plus y plus 9 equals 180. I'm still going to have an x and a y to deal with. But if I look at these 2 angles, my x plus 8 and my 3x, those I can add together because they're both x's. And I know that together they're going to make 180 degrees. So let's do that. X plus 8 plus 3x equals 180. Now I'm going to combine like terms. We are not doing like we did yesterday when we solved and we moved the x by subtracting it. I'm not going to subtract an x. Both of these x's are on the same side of the equal, so they just get combined to make 4x plus 8 equals 180. Now I need to move to the other side of the equals. So now I'm going to subtract 8 on both sides. And 4x equals, I believe that's 172, but it doesn't hurt to check. 180 minus 172 is 8. Or sorry, yes. what did I do there? Just kidding. 180 minus 8 is 172. I'm going crazy here. 172. Okay? All right, so now I have 4x equals 172. I'm going to divide both sides by 4. And x equals 172 divided by 4 gives me 43. So I have x is 43. Well, now I could plug that in over here so that I could find y. I know x is 43. So let's find y. 3 times x equals y plus 9. So 3 times 43 is 129, and that equals y plus 9. I'm going to subtract 9 on both sides because I'm moving to the other side of the equals, and I'm going to end up with 120 equals y. So I found x and I found y using the properties that opposite angles are congruent and consecutive angles are supplementary. I had to use both of those properties in order to solve for that. Okay? Alright, in the next video we'll pick up with number 2 and we'll figure out which of my 4 properties that we are going to use to solve for x and y in number 2. Come on back. See you in the next video.